In this video, we're going to look at how to create different numeric summaries in R for quantitative variables, as well as create box plots. So to get started, to follow along with the video, you will want to find the script that is located above the video to follow along. Alright, so starting out here, the first thing I'm going to do is read in the data set that we created in Module 5. So remember that in order to read in a data set, you first want to set your working directory. That's the place on your computer where you have the file stored. So as a reminder, how you can get this line of code is down here in the bottom right-hand box if you click on Files, and then click on the three horizontal dots. This will open up a file explorer on your computer. Remember, this is only going to show the folders. It's not going to show any of the files. And so from here, you can navigate to the place on your computer where you have the files for this course. And then when you click open, you should see the files appear here in the bottom right-hand window. And so I'm going to be working with the Kentucky data. When you go to do this for your data set, you'll want to use the data set that you've been using for your report. So depending on the topic of your report, you may have your data further subsetted, not just for your state, but it also may be just for men or just for women. Okay. And now to set the working directory, we click More. Oh, sorry, not More. Click on the gear, and you'll see one that says Set as Working Directory, and that will generate that line of code. And then just for future use, you can always copy that and then paste that here. You do want to be sure, do not run the line of code that has the file path for my computer, because obviously it won't work on yours. So next we're going to read in the data set. Again, I'm going to be reading in the Kentucky data set. So this line of code is very similar to what we've seen before. I'm going to be using the read.csv function. And you'll notice that I have the name of the CSV file that I created here in between the quotation marks. And I'm going to name this the Kentucky data. So when I run this, you should see the Kentucky data appear up here, or if you're following along with your data set, whichever data set is yours up top. And we see we've got 2,869 observations of 18 variables. That's exactly what we've seen before. And then it's usually a good idea to take a quick look at the data set just to make sure everything kind of looks okay, there's nothing unexpected. And there's two different ways we could do that. We could either use the view function, and be careful, this is a capital V, or we could double click on the data here. So when we do that, we open up the data set and we can kind of scroll through, and everything looks like it did before. And then I'm just going to close that. All right. In the next section, we're going to calculate different descriptive statistics for two different variables that we've seen previously. There's the phys health variable as well as the BMI variable. And so we previously created histograms of both of these, and now we're going to create several different numeric summaries. So just like before, we are going to be using the tidyverse later on, so I am going to go ahead and call library tidyverse. You'll see these messages down here, that's perfectly fine. Now if you're working on a different computer than you worked on before, don't forget that if you have not previously installed the tidyverse, we do need to go up to Tools, Install Packages, and find the tidyverse just like we did in the last video. But again, if you've already done that on the computer you're currently working on, you don't have to do that step again. You only have to run the library line. All right, so we're going to look at the phys health variable. This is the one that was located on page 19 of the code book. And so just like when we created histograms, we want to do a couple preliminary checks of this data set. So the first thing we're going to do is we're going to find the number of missing values. And we can do that using this line of code right here. We can see there is one missing value. And then I'm also going to make a table of this variable. And if you'll recall, I'm not going to create this table to actually summarize the variable. This is just a way to give me a quick visual check of the different values this variable is taking. And so if we look down here at the bottom, we can see that there were 74 people who responded 1 day of poor physical health. There were 296 that reported 30 days. And then a couple things just to remember for this particular variable that we saw previously. there are also 77s, 88s, and 99s for this variable. Now these don't actually represent number of days, or at least as they're stated. If you'll recall, the 88 actually represents 0 days of poor physical health. And then the 77 and the 99, those are the ones that represented the don't knows, the unsures, those types of values. So we do want to document those. So I've got some comments here that I'm going to fill in, very similar to what we did for the histogram. So for the Kentucky data set, there was one missing value for this variable. There were 1,815 88s. There were 36 77s, and there were 10 99s. Now, of course, for your data set, that is going to differ. Now, in order to actually work with this variable and to calculate numeric summaries, I need to take out those 77s and 99s because those don't actually represent numbers, and we need to convert the 88s to be a 0. This is the exact same thing we did when we worked with the histograms previously. So I'm going to run this line of code. And so as a reminder, what this line of code does is it takes the original physhealth variable and it creates a new one, and we call it physhealth new. And this physhealth new should now have all the 88s converted to zeros and the 77s and the 99s converted to missing. And we can always double check that variable, and it's a good idea to do that just to make sure it did what we wanted. So notice now if we look at our Kentucky data set, we can see we now have 19 variables. And again, if I click on it and I open up the data set, if I go all the way to the end, I should see that new physhealth variable. So if we look at the very first observation going across the first row, and we find the original physhealth variable, we can see it's right here. Notice that the first row had a physhealth variable with value 88, and we can see for our new one that 88 was converted over to a 0. The second observation had the value 7, and the 7 remains the same. And so it's always a good idea to just do a couple spot checks to make sure we get what we wanted. And again, we can see the 77 was converted to a missing, so everything looks good. So again, I'm going to close the data set. And again, just like with before we made the histogram, it's a good idea to check that new variable. So I created another table. We can now see there's 1,815 zeros, which is exactly what I would expect, and the 77s and 99s have been removed. And then we want to see how many values are actually represented in this table. And we can see there's 2,822. So again, I'm going to make a note of that. And notice if we took that 2,869, the total number of observations for the data set, and we subtracted off the number of missing, the number of 77s, and the number of 99s, we would get the value that we have right here. All right, so up to this point, we've actually seen all of this code last week. This was all pre-work that we needed to do before making a histogram. This is also all pre-work that we need to do before actually calculating any of the descriptive statistics. So up to this point, hopefully all of that code looks somewhat familiar from last week. So now we can actually compute some descriptive statistics for this particular variable. Some common ones that we might want are going to be things like the mean, the standard deviation, the minimum, the maximum, things like that. So to calculate the mean, we're going to use the mean function. And so you'll notice I'm calling the Kentucky data set, and from the Kentucky data set, I'm calling that new physhealth variable that we just created. I then have a comma, and then what this piece of the code stands for right here is NA.remove equals true. And what that is telling R to do is before you calculate the mean, I want you to remove any missing values. If we don't have this piece and there's missing values for that particular variable, we will get an error. And so that's why this particular piece is important, because it's telling R, I want you to ignore all the missing pieces and just use the numeric values. So if we calculate the mean, we see the mean is equal to 5.12. If we calculate the standard deviation, we can do that using the SD function. Other than that, everything else is the same. We find the standard deviation is equal to 9.75. And then the summary function, this will actually give us lots of different descriptive statistics. So running that one, we can see that the minimum was 0, the maximum was 30. It actually tells us how many missing values there were. There were 47. And again, that's because we converted the 77s and 99 over to be missing. This one also gives us the mean as well as the median for this particular value. The only thing it really doesn't give us is the standard deviation. And then also notice for the summary function, we didn't need that NA.RM equals true because this function automatically accounts for that. All right, so typically when we look at descriptive statistics using R, we only use R to calculate their values. We don't actually use the output of R directly. We don't copy and paste that directly into a document. We have to do some formatting for it. And so as an example, when you go to look at the worksheet for this module, you'll see this table right here. And so notice what I've done is I've used R to calculate the different values in the table, but then I formatted the table in R. So some information that I have here. For the number of poor physical health days variable, one thing to notice here is I've given it a descriptive name. I haven't used that name from the data set because it's not very informative. Instead, I've actually given it an informative title here. Next to that, I've given the total number of observations for this variable that are not missing. And that was where we calculated this right here. So that's where that 2,822 come from. In the next line, I have the mean and the standard deviation for this particular variable. And you will often see in tables, this is how this is presented. You'll have the mean and then in parentheses, standard deviation. So you'll notice here, I have the mean rounded to 2 decimal places, as well as the standard deviation rounded to 2 decimal places. And again, both of these are coming directly from the code. And then I also have the median, and then in parentheses, the minimum and the maximum. So for this particular variable, we can see that the median was 0, the minimum was 0, and the maximum was 30. And so again, for quantitative variables, you'll often see multiple descriptive statistics given, and that's because really to get a full picture of that particular variable, we need to give all of these values. So for example, notice that both the mean and the median give us an idea of the center of the data, but we can see they're not equal in this case. And in this particular case, the mean is greater than the median, and this suggests that this data is right skewed. And what's happening for this particular variable is there's a large number of zeros. And this large number of zeros is causing the median to be 0. And so this tells us that half of this data set, or probably half of the values for this variable, are actually equal to 0. And then what's happening is we do have quite a few people that have reported having 30 days of poor physical health, and that is skewing the data to the right and pulling the mean away from the median and closer to that maximum of 30 because we do have quite a few observations at 30. And so again, this is just showing that this particular data set is right skewed, but if we only reported the mean or the median, we wouldn't be able to see that information. All right, next we're going to look at the BMI variable. So this variable is located on page 143 of the codebook. Just as a reminder, in the codebook, the name for this variable is underscore BMI5, but R doesn't allow variables to start with an underscore, so it automatically places an X in front of them. So similar to the previous variable, we're going to do some preliminary checks. These are the same preliminary checks that we did before creating the histogram. We'll first look and see if there are any missing values for this variable, and we can see that there are 200 missing values. So again, I'm just going to make myself a note here using a comment. And then similar to the other variable, I could create a table, but for BMI, it's not particularly useful because BMI takes so many different values. But one thing that I can see from this table is recall from the code book that that BMI variable has 2 implied decimal places. So for example, if we see the value 1,221 in the data, that actually means a BMI of 12.21. So we want to, again, create a new variable that's in a format that's easier to work with. And again, this is the same thing that we did for the histogram. So starting with my data set, I'm going to take my original BMI variable and create a new one. And that new one is going to be equal to the original BMI variable divided by 100. And so again, this is where we're going to actually get that decimal place. So running this line of code, and then again, just doing a quick check here, looking at the table, we can now see that these have been converted, and we do actually see that decimal place, which is what we would expect. And then last thing we're going to do is if we sum the table, that will again tell us how many observations we actually have for this variable, or how many different values, and we can see that we have 2,669. And this matches what we have up here. The full data set has 2,869 observations, but we know that 20 of them are missing for the BMI variable, so the 2,669 matches what we've seen before. So again, up to this point, we saw all of this before creating the histogram for the BMI variable. So this is all repeated. And so now we have the new piece here. And so just like with the physical health variable, we're going to calculate the mean, the standard deviation, and then use the summary function to give us things like the median, the minimum, and the maximum. Now we can actually run all 3 lines of code at once, and so that's what I'm going to do here. And my output appears. So again, I'm using R to get the output, but I'm going to format everything in Word. And so going back to the example for the assignment, you can see here, I have the BMI variable. Again, I'm not using the name that's in the actual data set. I'm giving it a meaningful name in the table, as well as the units of measurement for BMI. N is going to be equal to the number of values that I have for BMI. I have the mean and the standard deviation rounded to 2 decimal places, and you can see those are both coming from here. And then we also have the median, the minimum, and the maximum. Now notice one thing that is different compared to the physical health variable. Notice here that the median and the mean are actually fairly close to one another. So this would suggest that this variable is fairly symmetric. We probably don't have a high skew in our BMI variable. And if we go back and we look at our histograms for both of these variables, we can actually see that that's exactly what we saw previously. So this is how you're going to place the values in the document for your worksheet. And so the last thing we need to do in the code is we're actually going to create a box plot, and we're going to create a box plot of the BMI variable. So to create the box plot, we're going to be using the ggplot function. This is very similar to when you created the histograms, except here we're now going to have the gmBoxPlot call. So highlighting this, if we run it, now notice it is going to give you a warning. Those 200 rows that were removed, those are just the missing values. Okay, so don't forget you can always move your window to make your box plot easier to see. And so now we have a box plot of BMI. So just kind of a reminder on how to read box plots. The middle vertical line, that is where the median is. So notice the median for this particular variable was equal to 28.13. And we can see that that vertical line falls right about at 28.13. This vertical line and this vertical line represent the first quartile and the third quartile. They tell us where 25% and 75% of the data are respectively. So for this vertical line, 25% of the data fell below this value and 75% fell above this value. And again, if we look at the output, making this a little bit easier to read, we can see the first quartile was at 24.33, and then the third quartile was at 32.84, about right here. And at the third quartile, about 75% of the data falls below this value and 25% falls above. The lines, the horizontal lines on the box plot, go all the way to the minimum and up to the maximum, which is not an outlier. And so here, all of the dots are outliers, and then the maximum, which was not an outlier, occurs right here. And on the lower end, we can see there were no outliers. All right, so the last thing you'll want to do for your assignment is you'll notice after you create the table, the last thing I do ask for is a box plot of the BMI variable. So as a reminder, to put the box plot in the document, what you can do is click on Export, Save as Image. You'll want to give it a new name, and you can change where on your computer you want to have that saved. And that will save the image to your computer so that you can then insert in the document. And you can move the windows around to get the box plot how you want it and then save the image. All right, so that's how we work through all of the code for this particular assignment. So just like the other assignments, I have provided a script for you on Canvas. So with the assignment, this is what the script will look like. So now let's go through and talk about how you'll want to change the code for your particular data set. So this example script is broken into 3 pieces. We have the section where you're going to read in the data, the section where you're going to find the values of the descriptive statistics, and then the last one where you're going to make the box plot. So for the read in the data section, you'll want to copy this section of the code. And then very similar to last week, you'll want to make sure you have the correct working directory. You'll want to change the name of the data set to be your data set. And then the view piece here is optional. You can leave those lines out since you could always just double click on the data set here to look at it. Next, for the values of the descriptive statistics, you'll want to copy everything over from the Calculate Descriptive Statistics portion. And then, very similar to when you worked with the histogram, you'll want to go through and everywhere you see the Kentucky data set, you'll want to put the name for your data set. So here and here, nothing else needs to change. This is the names of the data set. Same thing here and here. And then you'll want to go through and change the values in the comments to match, and also up here as well, change the values in the comments to match the values that you see in your particular data set. And then down here, again, you'll change the name of the data set. That will give you your new mean, standard deviation, minimum, maximum, and median for your particular table. So when you go to complete this assignment, you won't want to have the Kentucky values here. You'll want to put the values for your state. And then of course, you won't want to say Kentucky. You'll want to have the name of your state and then the total number of observations for your state. And remember, this total number of observations, that just comes from up here. You'll do the exact same thing for BMI. You're just changing the name of the data set. Nothing else needs to be changed. And then for the box plot, again, we'll just copy over the code for the box plot. And then the only thing you'll want to change here is the name of your data set. And then you'll also want to change the value for the total number of observations that's in the title for the box plot. All right, so as always, if you have any questions on the code, you're getting any errors, feel free to post those to the discussion board. I'm more than happy to take a look or to send me an email. Again, keeping in mind, it's not a coding class. We are using some coding, but you're just making minor changes to it to find the plots and the summaries that you need for your particular state. So again, if you have any questions, please feel free to reach out and I'm more than happy to help.